So now, vector notation. Now this is pretty simple. It's just simply how do we write a vector in physics. So you know, a vector is a quantity that we need to, in order to fully describe it, we need to specify its magnitude and its direction. So let's suppose we have a point A in here, and we also have a point B up here. If we have a vector between these 2 points, maybe this could be distance, displacement, or velocity, for example. Now, what we could say is that these 2 vectors, or the way to represent that, is just simply AV and an arrow on top. This is probably a notation you have seen before, and this is just simply saying that we're gonna have an initial point, which is A. This is our initial point. And you also have a final point, or maybe, yeah, something that marks the end of your magnitude, and that also to some extent determines your direction, which would be our endpoint. That's supposed to be an arrow. Our endpoint. This is our endpoint. And the arrow on top is just simply saying that A and V is a vector, or AV is a vector, or those are the elements of a vector, for example, or the 2 points in which that vector is happening or expressing itself. So another notation that is absolutely the same as this AV arrow is the same as if we said A arrow. In this case, in this type of notation, we're just saying that there is an initial point, which is in A, or an initial position or whatever that is in A. Okay, and the arrow, same thing, is just saying that that is a vector. In this case, we're not specifying the end point, but we're saying what the initial point is. Now, these are probably the 2 most common ways of representing a vector. If you have this, you could also maybe say it. It is not like a convention in physics to use capital letters, so you could also have like lowercase letters, you know, anything you want it. So these are like the main 3 notations that you might see. Now, how do you define, or how do you compute, for example, the magnitude of a vector? Now, this is pretty cool. Now, if we have a plane of coordinates, for example, like this one, let's say, and we have x and we have y, you guys know how it goes. Now, let's suppose we have maybe the vector that goes from point A, once again, that's A, and it goes all the way up here to point V. Now, what is the magnitude of this vector? In a plane of coordinates, we say that the magnitude of a vector is the distance between the 2 points, initial and final point, of the vector. So in this case, in terms of notation, we say that the magnitude is equal to the absolute value of the vector AV, and this is magnitude, and we know, since it is the distance between the 2 points, we know that we can compute that as the square root of, you guys should remember this equation, x minus x2 minus x1 square plus y1 y2 minus y1, same thing as with the x values, minus y1 squared, and all of this inside the square root. So this is the magnitude of a vector, and that magnitude is equal to the difference, or the difference in the x coordinates square, also and added to the difference in the y coordinates square, and all of that taking the square root of all of that. Okay, so this is the equation that you need to know for finding the magnitude of a vector. So let me give you an example about how we can maybe doing some writing with vectors, with vector notation, so you can get the hang of what is actually going on and how do vector notation works. So let's suppose maybe, for example, we have a road, and now in this road we're gonna have probably 2 states or 2 positions. Let's suppose in this very cute road we're gonna have a car, And now, in this first position, let's say the car is traveling at a velocity to the east. Let's suppose it is moving that way. Remember, you have north, east to the right side, and west and south. West to the left side, and south in the bottom. So now let's suppose it is going that way, and let's say it is traveling at 50 kilometers, however you want to say it, per hour to the east, because velocity is a vector, remember. And now when you write it, you also want to specify that where or the direction of the vector, to the east. Now I'm going to say that this car is also traveling when it takes this turn. Let's say the car is now traveling at, that's the same car, yeah, let's suppose, yeah. It looks so ugly, but yeah, it's a car. Now let's say this car is now traveling north, and let's say it's probably traveling at a speed of 100 kilometers per hour. Now we know these are vectors, and now I'm gonna say that this vector is equal to v1, velocity 1, and this vector is v2, velocity 2. Now in this case, what we could say is that since we know the magnitude of a vector is how big, or well, it's the distance between the 2 points. In this case, it would be from 0 to 50 in a coordinate plane. Well, no, actually, no, it wouldn't be that, but I mean, you guys know what I mean. You guys understand it. Initial points and the distance between those initial and final points. Now, we know the magnitude in this case, or that distance between the 2 points, is twice as big in v2 than it is in v1. So something we could say is that v2, or the absolute value of vector 2, and actually I missed the arrows in here, the magnitude of vector v2 is 2 times the magnitude of vector v1. Okay, so I hope you guys see the logic in here. Vectors, they're just simply quantities, and you can play with those quantities, add coefficients to those quantities as we did in this case. And here we're saying that v2 is twice as big as v1, which means that the car velocity doubled between these two. I mean, in the time these two vectors happen, or yeah, between these two moments. So I hope you guys enjoyed this video, and hopefully you got some idea of how we write vectors, and well, basically they're just pretty much algebra that you can do with them, okay? So see you in the next one.